Recording in progress.
From Electrical and Electronics Engineering. And my today's data structure tech talk topic is high-tech, high-sec security concerning graph databases. So cybersecurity measures are best accommodated in the system because their retrofits can be costly. New technologies and applications, however, brings new security and privacy challenges. Furthermore, the consequences of new technology adoption are difficult to anticipate. Such is the case with Graph database, a relatively new database technology that gaining popularity. These articles explore the value of Graph database and probe some of their security and privacy implementation. The emergency of number of SQLs. The relational database management system initially designed to maximize highly efficiency storage has indeed proved to be highly effective in transaction-rich and profitable environments. For example, the RDBMS excels in large-scale credit card transaction processing and cyclic billing operation. The RDBMS offers superior performance in the realm of index practical data, but it fades popularly in highly dynamic environments such as a management of information system that depends on volatile data or a system architecture in which the churn of many-to-many relationship is high. In such environment, the RDBMS design imposes far too much mathematical manageable overhead. The emergence of the not only structured query language but database represents an alternative to the decades long region of the RDBMS. Various forms of NQL databases opened doors to a vastly improved dynamic data portrayal with far less overhead and performance penalty. For example, schemas need not to be ri- rigorous in the SQL world. No SQL database design includes wide cloud storage stores, document stores, key value stores, multimodal database, object database, grid or cloud databases, and graph databases. The graph database crossing many lines in the NoSQL world. Two stands poised to become a successful technology. The graph database. The graph database relies on the familiar node or node relationship, or perhaps more simplistically a noun verb noun relationship of a network. A node can be any object, and arc represent the relation between the nodes, and the nodes and arcs can contain properties. This simple node or node trade often is a triple is the fundamental building blocks for designing all manners of complex in great detail. Networks such as an electric grid, a corporate supply chain, or an entire ecosystem are often composed of numerous nodes that share huge number of multiple relationships across arcs. Networks of all kinds lend themselves well to graph representation. The graph database harnesses this powerful capability to represent network composition and connectivity. Graph databases have matured to support discovery, knowledge management, and even prediction. In an internet-connected world where network of all types become increasingly primitive, such a network capability is becoming essential to modern sense making. However, like the RDBMS, the graph database is just another tool in the box and it can be harnessed for good or ill. Thus, it is not premature to consider the large scale security implementation, IT trends, graph discovery, because they deal with properties and connections. Graph database represents rich pools of information often hidden until discovered. Discovery is a means by which a large collection of related database is mined for new insights without a strong pre-organization, and these insights might be the graph database wasn't initially considered a useful tool for discovery. It took a specially designed family of supercomputers to realize the power of graph discovery. Although it's straightforward to represent graphs as the volume of triple increase into the billions, the ability to rapidly transfer multiple paths become compute bounds in all but the most powerful machines. This is particularly true in the case of dense graphs such as tightly woven protein networks. Here, detailed graph queries can overwhelm lesser capable computational systems. The graph supercomputer built from the ground up to traverse graph overcomes time and capacity limitations. Such devices, some complete with Hadoop analysis tools, recently become available on the high-end graph database marketplace via Crazy Computers. So these are the chart of graphs. Here we can see fundamental graph reasoning. The simple node or thread, often called a triple, is the fundamental building block for describing all manners of complex network in great details. So the high-end graph supercomputers built for discovery bring great promises. For this, it can support a detailed build-out of the complex relationships between the atmosphere that compose climate conditions. In a time of great climate changes, further discovery of atmosphere in a further discovery of indirect, non-linear causes and effects become increasingly crucial. Likewise, a graph supercomputer could hasten a discovery concerning the spread of Ebola in Western Africa, which could serve to stem the spread of diseases. Discovery, privacy, and security. Graph discovery, which has great promise for resolving complex interrelated problems, however, presents privacy and security concerns. For example, one's identity can be further laid bare if the graph supercomputer becomes the device of choice to further mine mine our social and financial transactions for purpose of surveillance, target advertising, and other over exploits that tend to rob individuals of their privacy. While, while perhaps an alien thought in a thriving free enterprise system placing and the acceptable extent of institution into one's personal life might prove necessarily financial, if not constitutional, reason. It's quite acceptable to law to expect enforcement use of all necessary means to remove real threats from our mind, but at what expenses to the rest of the society. Likewise, those engineers to move their product will take a database necessary for discovery. Such discovery could support a detailed build out of the complex relationship between ocean and the atmosphere that compose climate conditions, or could hasten the discovery of how Ebola might spread in Western Africa. This simple node, or can often call a triple, is the fundamental building block for desire of all manners in the great details. Basic building blocks, the triple non is the reality is that such end exploitation amounts to nothing more than a project of certainly established trends. In the design of such social and economic studies, especially involving a wide range of business transaction relationships, The security bar must be set exclusively highly intentional. Perpetrated breach could be far more devastating than the recent massive hack against corporations such as credit card issuers or motion picture companies. That is further aggravated by the notion that the Internet of Anything consists of myriads of sensor actuators and mobile devices, all of which seems to be optimized for privacy leakage. The node or concept is highly connected to the subject predict object relationship expressed using the resource description framework. RDS creates a level of formal expression that lets you describe and reason about the data housed in a graph database. Moreover, RDF nicely feeds a formal ontology, thus permitting a rigorous semantic definition of terms. The how much is enough question, however, might take years to resolve with regard to a tolerable degree of partial formalization. Together, RDA and a formal ontology speak to the World Wide Web Consortium view of linked data and endeavor to make reusable structured knowledge generally available in a common referential format via web. Failure to offer adequate protection could disqualify others promising candidates. Database offering whose interfaces are nothing less vulnerable to attack is further aggravated by the notion that the Internet of Anything consists of myriads of sensors, actuators, and mobile devices, all of which seem to be optimized for privacy leakage. The node or node triple concept is highly connected to the subpredict object relationship expressed using the resource description framework descriptive language. RDF creates a level of formal expression that lets you describe and reason about the data housed in a graph database. Moreover, RDF nicely fits a normal ontology, thus permitting a rigorous sentiment definition of term. The how much is enough question, however, might take years to resolve with regards to a tolerable degree of practical formalization. Graph prediction and dynamic circumstances involving an unfolding process such as a weather or even trends, the ability to predict further behavior becomes highly desirable. Graph representation facilitate prediction because they let us both qualify and quantify a system represented as a network. The ability to assign properties to nodes and arcs such as location, time, weight, or quantities let us qualitatively evaluate the graph on the basis of similar properties. More importantly, quantitative techniques let us evaluate metrics inherent in almost all graphs. This applies to many fields, including numbers and prediction, security, and privacy. Current cybersecurity based practices suggest the importance of taking a snapshot of the system under study to determine its security and privacy vulnerabilities, leading to the accreditation of systems proven to be secure. The fallacy of such practice is that most systems are influenced by ever-changing environments which serve to change systematic behavior over time. Thus, the accreditation is good for the moment of time in which the snapshot was taken. Thank you.